Hey guys, I figured I'd go ahead and start from the beginning for those that missed on Friday. So, 2.8 is about modeling using variation. And like I said in class on Friday, um, it's about, well, you're going to run into problems like using variation on the ACT and in standardized testing. And it'll just be one of those things that you just have to remember uh, what they mean when they talk about direct variation versus indirect or inverse or proportional to. So yeah, I'm just going to teach you about the different kinds of variation you can have and how to set up those equations and what they're actually looking for. So just as an example, it says when you swim underwater, the pressure in your ears depends on the depth at which you're swimming. The formula P equals 0.43 D describes the water pressure P in pounds per square inch at a depth of D feet. So the pressure depends is 0.43 times the depth, right? So if your depth is 1 foot, then the pressure is 0.43 times 1, which is 0.43. If the pressure, if the depth is 10 feet, then the pressure is 0.43 times 10, which is 4.3. And this is pressure in pounds per square inch, so PSI. And if the depth were to be 100 feet, then it would be a pressure of 43 PSI. So the relationship between the variables is such that as the depth gets larger, as you go from 1 to 10 to 100, the pressure also gets larger, 0.43 to 4.3 to 43. So they have a relationship such that when one grows, so does the other, and that's called direct variation or directly proportional to. So direct variation, something you're going to want to write down your notes, says if a situation is described by an equation in the form y equals kx, and so k is that part where most people don't realize that they need to work, or they need to put that in the equation. So it says where k is a non-zero constant, we say that y varies directly as x, or y is directly proportional to x. The number k is called the constant of variation, the constant of proportionality. So you'll see on an ACT question where it says this varies directly with this. What would this be if that's that? It's like you've got to use that first piece of information to solve for the constant of variation. Okay? So if you wrote anything down in your notes, I would write direct variation, y equals kx. I would put y varies directly as x, and then y is directly proportional to x. And then maybe write down k as the constant of variation or proportionality. Okay? So an example would be the volume of blood, B, in a person's body varies directly as the body weight. And so with the whole growing at the same rate, direct variation, I always just think it's you're multiplying. So it's k times x. It's directly across the equal sign, which is kind of what I see, I guess, when I'm working it out. So the volume of blood varies directly, so some constant of variation times the body weight. And then they give us two pieces of information. A body that weighs 160 pounds holds approximately 5 quarts of blood. So then the question is, if someone weighs 200 pounds, no, just kidding. If someone weighs 200 pounds, then how much blood would they have? So what you have to do is use this first set of information to solve for the constant of variation. So we would divide 5 by 160, and you get k equals 0.03125. And so I know that the volume of blood equals 0.03125 times the weight. So if the weight is 200, then the volume of blood would be about 6.25 quarts, according to this data. Okay? And don't forget that if it's situational, go ahead and answer in units. Okay. Now, direct variation with powers, I mean, basically it's just, the point is that it doesn't have to be just the variable. You could say, you could say y varies, or is directly proportional to, y is directly proportional to the I'll go ahead and say the cube of x. So you would say y equals some constant of variation times x cubed. So it can be any kind of expression. It's just the direct proportion means multiplying, and you got some k. All right. So then this example says the distance s the body falls from rest is directly proportional to the square of time t of the fall. The distance s that a body falls from rest is directly proportional to the square of time. Okay? If the skydiver falls, or if the skydivers fall 64 feet, so that's distance, in 2 seconds, then how far will they fall in 4.5 seconds? So then the question is, what is s when t equals 4.5 seconds? Okay, so you got to solve here. 2 squared is 4, and 64 divided by 4 is 16. So then you're saying, okay, what is the distance if it's 4.5 seconds? And so you just fill in your k and fill in the time, and then it's 16 times 4.5 squared, which would be 324 feet. Okay? Inverse variation. So the distance from San Francisco to LA is 420 miles. The time it takes to drive from San Francisco to Los Angeles depends on the rate at which one drives and is given by this. Time equals 420 miles divided by the rate. So time equals 420 miles divided by the rate. And so if you think about like dividing by miles per hour, if you've got miles and then you divide it by miles per hour, when you flip and multiply hours divided by miles, the miles cancel out and you're left with hours, which is the time unit. Okay, so that makes sense as far as conversion goes. Okay, or you can think distance equals rate times time. Like if you multiply both sides by rate, you get rate times time equals distance. All right, so if you average 30 miles per hour, so if you have 420 miles to travel and you're averaging at 30 miles per hour, then it would take you 14 hours, which would be brutal. But if you're traveling at 60 miles per hour on average, and 420 divided by 60 would be 7 hours. So the reason why this is called inverse variation is as your rate, which was this variable down here underneath the constant of proportionality 420, as this got larger, the time got smaller. So that's the inverse variation, the inversely proportional to. As one gets larger, the other variable gets smaller, as opposed to direct where they're both increasing at the same time. Okay, so inverse variation in general, if the situation is described by an equation in the form y equals k divided by x, so inverse, I just always think reciprocal, it's in the denominator. It's not direct, it's indirect. Where k is a non-zero constant, we say that y varies inversely as x, or y is inversely proportional to x. The number k is called the constant of variation. Okay, so definitely again write down inverse variation, this, and then y varies inversely or inversely proportional to on your green sheet. Okay. If the temperature is constant, the pressure P of a gas in a container varies inversely as the volume. So I would say pressure is some constant variation divided by volume. The pressure of a gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. So if I want to solve for K, then I could say K equals 12 times 8, which is 96. And then if the sample expands to a volume of 22 cubic inches, so if K is 96 and the volume is 22, then I can find the new pressure. And that would be 96 divided by 22, which is 4.364 if we round. And the pressure is measured in pounds per square inch, so PSI again. Okay, combined variation. So combined variation is where it gets a little bit more interesting. In a combined variation, direct and indirect variation occur at the same time. They don't have to, but combined variation is just multiple. Yeah, combined is a mixture of those two. If y varies directly with w, so constant proportionality times w, and indirectly with z, so we're dividing by z, then the equation that would express the relationship is y equals kw divided by z. So you can have multiple at one time. Okay, so suppose x varies directly. You might like pause this maybe and try and work this problem on your own, but anyway, here we go. So I'm trying to get the focus. Okay, suppose x varies directly with the square root of r and inversely with z. Suppose x varies directly with the square root of r, so some constant proportionality times the square root of r, and inversely with z, or is inversely proportional to z. So then this is my equation relating my variables. So it says if x is 1.115, when r is 94 and z is 2, then what would x be if r is 183 and z is 4? So I need to solve for the constant proportionality. So the first thing I'm going to do is multiply by 2 and then divide by the square root of 94. So 1.115 times 2 divided by the square root of 94. And I get that k equals 0.23. And we'll just go with that because of all the zeros. So if I know what k is, then I can say 0.23. And if r is 183, so it's the square root of 183, divided by z, which is 4, then I can solve for my new x value. So 0.23 times the square root of 183 divided by 4. And I get x equals 0.778. Okay. All right. It says solve the equation for the variable r. All right. So if I have x equals k times the square root of r divided by z, and I need to solve for r, then I'm going to multiply by z. I got some of you guys, when you're multiplying both sides by z, you're multiplying this by z as well and leaving it there. The point of multiplying is that it goes away, right? So that's gone. I'm going to divide by k. So, just not 2. Zx divided by k equals the square root of r. And then the inverse operation of the square root is the square, so I'm going to square both sides. So I've got r is z times x divided by k squared. So this says what would r be if x is 5 and z is 3? So z is 3, x is 5, k is 0.23, and we're squaring it. So 15 divided by 0.23 squared is 4253.308. And there you go. Okay, so one last type of variation, joint variation. It says, in joint variation, a variable varies directly with a product of 2 or more variables. If y varies jointly with as x and z, then the equation that would express the relationship is y equals k times x times z. So if you're jointly varied with, if there's a joint variation, then it's multiplication of 2 other things. It doesn't have to just be variables. So it says, for example, this centrifugal force C of a body moving in a circle varies jointly, which means there's going to be double multiplication, with the radius of the circular path r and the body's mass m, and inversely with the square of time, so time squared. And so there you go, that would be your equation, right? So let's do one example. Okay, suppose A jointly varies with the cube of B and the difference between C and D. So suppose A varies jointly, so some constant of variation times the cube of B and the difference between C and D. Okay, so I've got A equals some constant of proportionality times B cubed times C minus D. Solve the equation for D. Okay, so if I want to solve for D, there's a couple different ways to actually approach this. I'm going to go ahead and just start moving things, and then I'll talk to you about another way. So I would divide by K and B cubed equals C minus D. And then maybe you want to subtract C. An easy way to do this would be add D over here and subtract that, but that's whatever. So if we subtract C from both sides, then I'm left with A over K times B cubed minus C equals negative D. Don't forget the negative part. And then divide by negative just means make that plus, make that minus, make that plus. So we divide by negative. So D equals negative A over KB cubed plus C, or C minus all that. The other option is you can distribute. So A equals KB cubed times C minus D. If you distribute all of this, A equals KB cubed C minus KB cubed D. Then you could just subtract this over. A minus KB cubed C equals negative KB cubed D, and then just divide. Negative KB cubed, negative KB cubed. And if you simplify this, you get A over negative KB cubed, which is negative A over KB cubed, and then this divided by that is just plus C. So final answer, would move the negative out. Negative A plus KB cubed over KB cubed equals D. Okay, either way, they're the exact same. So it says if D is 3.303, okay. If D is 3.303 when A is 1200, so negative 1200, KB is 4, so 4 cubed plus 10, then what will D be when A is 560, B is 2, and C is 8.2? Okay, so we need to solve for K. And actually it probably would be easier to solve for K using this formula, just because all I would have to do is just divide by all of that. But since this is the equation I just wrote, I'm going to go ahead and do it. It's kind of up to you though. So if you see the other way better, then you can just do that. Minus 10, minus 10. So negative 6.697. 4.303 minus 10. Negative 6.697 equals negative 1200 divided by K times 64. Let's go do that. 4 cubed is 64. I'm going to multiply by K times 64, 64K. And those are both gone. So then I've got, I'm going to multiply 64 times negative 6.697 times 64. So I've got negative 428.608K equals negative 1200. And then I'm going to divide. So K equals negative 1200 divided by that number. And I get 2.7997, so we're going to go with 2.8. Okay, so we round to 3, and it goes there. Okay, so I've got K is 2.8, so D equals, I'm going to go back to this equation, but I'm going to rearrange it. C minus A over 2.8 B cubed. So then the question is, what will D be if A is 560, B is 2, and C is 8. And so then we just type it in. 8.2 minus 560 divided by 2.8 times 8. And that is negative 16.8. Okay. So what you're going to be asked to do is a variation of problems similar to this. And yeah, that's what you're going to do the rest of the period. So here's your assignment. Maybe pause the video and write those down. But there you go.